Welcome to G Fun Facts Online, where today we're leaving our solar system behind and traveling hundreds of light years to some of the most extreme, hellish worlds ever discovered. We're talking about planets so hot they can vaporize rock, with clouds made of minerals and rain made of molten iron. And our guide on this journey, the most powerful space telescope ever built, the James Webb Space Telescope, or JWST. For decades, planets beyond our solar system, called exoplanets, were just tiny wobbles or dips in a star's light. But now, JWST is peering directly into their atmospheres, unmasking the exotic molecules hidden within, and rewriting the story of how planets are born. Our journey begins with a world that makes hell look like a vacation spot, WASP 121b. Located nearly 900 light-years away, this planet is a type of exoplanet known as a hot Jupiter. It's bigger and more massive than our Jupiter, but it orbits its star in just 30 hours. This tight embrace means one side of the planet perpetually faces its star, baking at a mind-boggling 3,000 degrees Celsius. The other side, the night side, is a comparatively cool 1,500 degrees. The star's immense gravity has even pulled the planet into a distorted football shape. Using its powerful infrared vision, the Webb telescope stared at WASP 121b and found a cocktail of familiar molecules like water vapor, carbon monoxide, and methane. But it also found something never before seen in a planet's atmosphere: silicon monoxide gas. Silicon is a key ingredient in rocks. Finding it as a gas tells a dramatic story. Scientists believe WASP 121b didn't form in this fiery inferno. It was likely born much farther out in its system, in a cold region where it gathered up methane-rich ices. But gravitational chaos sent it on a death spiral inward toward its star. As it migrated, the planetesimals, or planetary building blocks, that it had consumed were vaporized by the intense heat, releasing their rocky contents, like silicon, into the atmosphere. So this planet carries the chemical ghost of its own violent past. So how do we know any of this? How can we sniff out molecules in an atmosphere hundreds of light years away? The primary method is called transit spectroscopy. When an exoplanet passes in front of its star from our point of view, a tiny fraction of the starlight filters through the planet's atmosphere. Different gases in that atmosphere absorb very specific colors or wavelengths of light. This leaves a unique chemical barcode imprinted on the starlight that reaches JWST. By analyzing this barcode, astronomers can identify exactly which molecules are present, from water to vaporized rock. It's like cosmic detective work on a galactic scale. And the discoveries are rolling in. JWST isn't just looking at WASP 121b. On a world called HD 189,733b, it found an atmosphere rich in hydrogen sulfide, the molecule that gives rotten eggs their lovely smell. Another planet, the super-Earth GJ 486b, orbits so close to its star that its surface hits 800 degrees Fahrenheit, yet Webb may have detected signs of a water-rich atmosphere. This is baffling, as the intense radiation should strip any water away. One theory is that the water is being constantly replenished by volcanic eruptions on the surface. Perhaps the most tantalizing discovery comes from a planet called K2 to 18b. It's not a scorching world, it actually orbits in its star's habitable zone. There, Webb detected methane and carbon dioxide, and a potential hint of a molecule called dimethyl sulfide. Now, here's the kicker. On Earth, dimethyl sulfide is only produced by life, mostly marine microorganisms. Scientists are urging extreme caution. There could be unknown, non-biological ways to create this molecule. But the very fact that we can detect such a substance is a monumental step in the search for life elsewhere. From rocky worlds with steamy atmospheres to gas giants reeking of sulfur, JWST is revealing an incredible diversity of planets. Each new discovery helps us piece together the puzzle of how planetary systems form and evolve, and it puts our own solar system into a grander cosmic context. The journey to understand these alien skies has truly just begun, and with future missions like the European Space Agency's Aerial Telescope on the horizon, the great cosmic census of exoplanet atmospheres will continue. Thanks for joining us on G Fun Facts Online. Tune in next time as we explore another amazing corner of our universe.